bus arbitration. So all of you know what is a bus. Bus is a set of wires within the system, within the computer, which connects the internal devices of the computer. So the internal devices, that is the input device, the output device. Okay, so peripheral devices, input device, the output device, memory, and processor. So all the functional units of the computer are connected, and the signals and data transfer through these buses. Okay, so the data keeps transferring between the buses. Sorry, this is a processor. So the data keeps transferring between this processor. Now there is an initiator. There is a unit which initiates this data transfer. Okay. So in most of the times, most of the cases, it is the processor which initiates the transfer of data. The processor wants to read the data from the input device. It initiates, it requests the keyboard to read the data. So the data transfer takes place from input device to the processor. Okay. So most of the times it is the processor which initiates the transfer of information and transfer of signals. Okay. So processor is the initiator many of the times. Okay. And the device, the unit which initiates the transfer of data through the bus, the device which uses the bus to start a particular action, so that device is called the bus master. Okay, that unit is called as the bus master, and most of the time it is the processor who's the bus master. So bus master is the device or the unit which initiates the transfer of data through the bus, initiates the transfer through the bus, so that is bus master. Now when the processor is transferring the data, okay, so processor is the bus master most of the times. Now you have seen the concept of DMA, direct memory access. So you had seen that in direct memory access, once the processor gives the authority for the DMA controller of a device, the memory is accessed from the DMA controller. The memory is accessed directly without the processor. Okay, so DMA controller is initiating the action sometimes. Correct. In DMA process, the DMA controller is initiating the action. In such cases, the DMA controller becomes the bus master. The DMA controller initiates the transfer of data between the device and the memory. Okay, so DMA controller becomes the bus master in some cases. So here there is a competition for the request for the access of the bus. Okay, that is to become the bus master, the device which initiates the transfer of data, that is the initiator, is called the bus master. Most of the times it is the processor, but there can be a request simultaneously from DMA controllers. I'm telling DMA controllers because many devices can have its own DMA controllers. Okay, and there can be a request from the processor also to access the bus. Okay, so there is a request from the DMA controllers and the processor for the bus. Okay, so there is a competition for the bus access. This process of selection, who should be the bus master, selection for the bus master, the process of selection for the bus master is called bus arbitration. Okay, so that is bus arbitration. Who should become the bus master? We will see different types of selection of bus master. Okay, how the selection is done for becoming the bus master. Okay, that is nothing but different types of bus arbitration. Fine, we'll see in this video about bus arbitration. Now bus arbitration, the device that is allowed to initiate transfer of the data through the bus is called the bus master. Okay, many of the times, most of the times, it is the processor who is the bus master, and it can be DMA controller in case of DMA access, direct memory access. The DMA controller becomes the bus master. Okay, the process by which the next bus master is selected and the bus mastership is transferred is called arbitration. Okay, so as I told, there is a need for selection of bus master in some cases when both, that is, DMA controllers, any of the DMA controllers and processor both are requesting for the bus. Okay, so the selection who should be the bus master selection is needed. Okay, and selection is done and the bus mastership, that is, the ownership of the bus is given to the selected bus master. So that process is called as bus arbitration. Two types of bus arbitration: centralized and distributed. So centralized means a central control, correct, a central control. So a single unit is present called the bus arbiter. It is a circuit which selects the bus master. Okay, many of the times the circuit is available within the processor itself. Okay, within the processor itself there is the arbiter which selects the bus master. Okay, and one thing to be noted is when there is a request from the processor and also the DMA controllers, the priority is given to DMA controllers. Direct memory access is given priority for having the control of the bus. Okay, so DMA process is given higher priority, fine, than the execution of other process programs. Fine. The next type is distributed arbitration. In distributed arbitration, all the devices which is participating for the bus mastership is involved in the selection of bus master. Okay, so all devices D1, D2, D3 all wants to become the bus master. Okay, so this might be DMA controller 1, DMA controller 2 device, and this can be the processor. All these devices are involved in the selection of bus master in case of distributed arbitration. In case of centralized arbitration, it is the central control, it is a single control. Okay, so a single bus arbiter is present. This is a circuit which selects the bus master. Okay, we'll see centralized arbitration first. So here, yes, bus arbiter. In this example, the processor is considered as the bus arbiter. You had seen in the previous diagram where you had seen the priority arbiter within the processor. Okay, similarly, there is bus arbiter within the processor. It can be a separate control unit or within the processor. Okay, so which gives the authority to the requesting device. Okay, bus requesting device. Now here we'll see these terms first. BR is bus request. Okay, so this is the line through which the bus request is moving to the processor, to the arbiter. Okay, so this is the unit bus arbiter, fine, within the processor. And bus grant, BG is bus grant. Okay, it is granting the bus request. Bus request is permitted. Okay, that is bus grant. And BBSY means bus busy. Okay, so that is bus busy signal. Now, any device which needs the control of the bus sends the bus request through this bus request line. So as soon as the bus request is request is obtained by the bus arbiters circuit, it grants the bus. Okay, it grants a bus, but bus can be used only if the bus is not busy. That is this. signal is not busy, BBSY signal is not busy, then the bus can be used. Fine. Now you can see the diagram here. You can see the bus grant. So bus grant is given for to one device, and then there is a movement from this device to the next device. So what is that here? So this is device 1 and this is device 2. The daisy chain mechanism of connection is used in this particular technique. So here what is happening is, suppose the device 2 request for the bus. Okay, device 2 request for the bus. The request moves from the device 2's DMA controller to the bus arbiter. The bus arbiter does not know from which device the request has come. Okay, it just sends the bus grant to the first device. Bus grant is moved to the first device. But suppose this it has not asked here. In this case, D2 has asked, isn't it? So this bus grant is not requested. The device 1 has not requested for the bus. So bus, it receives the bus grant and then forwards it to the next device. Okay, as the device D1 has not requested for the bus, it forwards to the next bus, next device. So device 2 has requested for the bus, so it uses the bus control if this bus busy line is free. Okay, bus is not busy. Fine. So it does not forward anymore the request because it needs the bus. Okay, it does not forward the bus grant signal. It uses the bus which is sanctioned. Okay, now suppose this is device 1 and device 2. Device 1 is sending the bus request. Device 2 is also sending the bus request. Both the devices are sending the bus request. Okay, so processor, what does it do? Processor gets the request, it grants the bus to the device 1. Grant means yes, you can use the bus if the bus is free. Okay, so it gets a grant. So the device 1 has sent the request and it needs the bus. It does not forward the grant. Okay, so the bus is used by device 1 itself. It uses the bus whenever it is free to send the data. Fine. So these are bus request and bus busy lines. Okay, these are separate lines. There is the actual buses through which the data and control signals and addresses are passed. There is separate lanes for it. Okay, and these are the request lines. It is different. Okay, so there is bus, data bus, there is control bus as you had seen in the previous video, there is control bus, and there is address bus through which the signals, address and data gets transferred. Okay, so these lanes are just for getting the control of these buses. Fine. So that is centralized bus arbitration. We'll just see the timing diagram of centralized bus arbitration. Here the bus request comes. Okay, bus request has come from DMA controller 2. So immediately as the bus request comes, bus is granted by the processor. So processor or the bus arbiter. Okay, so the bus arbiter circuit grants the bus request. Okay, so device 1 has not requested for the bus, so it is forwarded to device 2. Device 2 has requested for the bus, it will not forward this bus grant anymore. Okay, and it will wait for the bus to become free. Bus is being used by the processor here. Bus is being used by the processor. Bus is not free. Okay, bus is busy. At some time, bus becomes free. When the bus becomes free, it is informed that the bus is free. Okay, and then the bus is used by the DMA controller 2 for whom the grant is received. Okay, so the bus uses the the DMA controller 2 uses the bus. Okay, so here you can see it is being used by DMA controller 2. Okay, and then the bus, after the DMA controller uses the bus is freed. Okay, the bus is freed, and it can be used by any other device which is requesting for the bus access. Okay, so that is centralized arbitration. Now we'll see distributed arbitration. Okay, in centralized arbitration, the same, this slide we didn't see, it is the same. Request for the bus, the processor or the bus arbiter circuit which is there within the processor grants the bus grant signal. Okay, and bus grant signal is forwarded as in daisy chain mechanism. Okay, so if the busy signal is 1, it indicates that the bus is busy. Okay, and the bus master has to, the bus is busy and the requester has to wait. Okay, so this is centralized bus arbitration. Next, we'll see the distributed arbitration. In distributed arbitration, as I told, all the devices which are involved in the uh, bus request, okay, all the devices which are requesting for the bus are involved in the selection of the bus master, or they are involved in the bus master arbitration process. Okay, so as you know, bus arbitration is the process of selection of bus master, next bus master, and transfer of the bus mastership. Okay, so all the devices who are requesting for the bus are involved in the selection of in the bus arbitration process. Okay, there is no central arbiter, there is no central arbiter. So this technique, this mechanism, distributed arbitration, is each device is assigned a 4-bit ID number. Okay, so in this mechanism, that is distributed arbitration, each device, whoever is requesting for the bus, is assigned a 4-bit number. Fine. And using this 4-bit number, okay, using this 4-bit number, the next device who should become the bus master is selected. Okay, so usually it is the device which has the highest number which is given priority. Okay, so how it is selected? So yes, you will just see the circuit. So this is the circuit. This is one device which is requesting for the bus. Okay, so similarly there is another device. Okay, so there is, suppose, device B which has its own ID. Okay, so it will have its own ID, that is the voltages which is passed through this lanes. Okay, so this is the unique number of the device. This is the unique number of the device. Using this unique number, which bus must be the bus master is selected. Okay, so how is the selection done? What is the process of selection? So here, yes, you can see that there are 4 bits. Okay, so 4 bits indicates this using this arbiter lines. These are called the arbiter lines. Okay, so using this arbiter lines, the next bus master is decided. Okay, now you can see this, it contains, each device contains a 4-bit code. So these bits are connected to one line each. Okay, so we will take the example here. 0101 and 0110 are the two IDs, ID of device A and device B. Okay, now this ID is moved through the NOT gate, so the value becomes 1010, and similarly this ID is also moved to the arbiter line through the NOT gate. Okay, so the value becomes 1001. So here in arbiter line, if any bit has the value 0, then that particular signal becomes 0. Okay, so if any bit, that is the first bit here, the MSB bit is 1 in both the cases, then the value is 1, then that line will have the signal 1. Okay, so next bit is 0. So at by any device, there is the value 0 which is passed through in the second bit, so it is the 0 in the particular line. So here the third bit is 0 in this particular, that is device B signal, so the value is 0. Again here 0 is there, so the value is 0. So hope you have understood. That is, at any bit position there is 0 in the line, 0 which comes to that line. Okay, then the value set is 0. Only if all the devices has the value 1. Okay, if all the devices has the value 1 in that particular position, then 1 is set to the arbiter line. Okay, now, okay, so here at the MSB both is 1. Okay, we are considering only two devices, so the value in that particular bit is 1. Okay, so 1 is there. Now for the next line, 0 is coming here, and in the next here, this after the NOT gate, this also is giving 0, so it is 0 in this particular lane, and hence it is 0. Okay, now in this next case, 1 is there in this particular line, but the here the in the device B, the value in that particular lane is 0. Okay, so 0 is there, here 1 is there. As 0 is there in at least one of the device, then it becomes 0. Okay, so this is the value in arbiter line. So the value whatever is there in arbiter line, that is 1000, comes to these devices. Okay, comes to these devices. So there is a NOT gate there. As there is NOT gate, the value becomes 0111. Okay, 0111. Fine. So the value now, what comes back to the device from the arbiter circuit is 0111. Fine. Now these values are compared. These values are compared with the ID number of the device. Okay, so this is the ID number of the device. This value, whatever has come back from the arbiter line, are compared with our ID numbers of the device. So if it matches with the ID number, then the same number value is retained. If there is a mismatch, then 0 is put to that particular location and to the next lower bits. Okay, so that is the technique used. So for the device A, it's the MSB, start matching from the MSB, 0 matches, so put a 0, and then 1, so matches, so put 1, and then this is 1 and this is 0, so it does not match, hence the rest of the bits is 0. Okay, similarly match the value for device B also. Okay, so match this code for device B. 0 matches, the MSB value 0 matches, 1 matches, and the next bit 1 also matches. 1 and 0 does not match, so put a 0. Okay, now both the devices have the value 0 1 1 0 1 0 0, and here it is 0 1 1 0. Okay, this is again sent through the arbiter line. Okay, at in the next stages, you can see that the value at all the devices, whichever is contesting for this particular selection of bus master, will have the highest number. 0110 will be the value which is present with bus all the devices who's contesting for them bus mastership, that is highest value, highest id number. Now comparing a and b, the value of b is the highest, that is 0110 is the highest. So 0110 will be the value with all the devices. Okay, I'm not proceeding as it is, and the explanation with the code with this numerical is not required. Okay, but you can proceed further. You can see that once this 0110100 is there in device A and device B 0110 is there. Okay, it passes through this arbitration line, and the value of arbitration line is reframed. Okay, and you can see that all the devices will have the value 0110, that is the highest device number, id number. Okay, and that device which has the highest number, the particular device whose number is matches for all the devices is the same. Okay, whatever you get will be the same for all the devices. So thus all the devices are involved in the selection of bus master. Okay, we'll take one more example. You remember the circuit, there is not gate. Okay, and while returning also there is a not gate, returning of values from arbitration line. We'll take one more example. So if I take 0001 as the id of device A, and for device B I will take the example as 0111. Okay, now finally device A also must get the value 0111. That is, any number of devices which might be competing for the particular bus master, all devices. So suppose C is 0011 and the id of D is 0101. Okay, so finally all the devices should have the value 0111. That is, you are selecting one single device to be the bus master. Okay, so how it is done is, now here for simplicity I'll just take these two devices A and B which has this id. Okay, now the first step is, whenever the id is there, negate it. Okay, there is a not gate, so negate it 1110 and B becomes 1000, and it passes through the arbitration line. Okay, if at least one bit is 0 in the position, then the value in the arbitration line is 0. So I get the values in arbitration line as 1, both is 1. Here it is 0. One bit at least is 0. So the value becomes 0. And this is the value what is there in arbitration line. Okay. From the arbitration line, it comes to the NOT gate and then to the device. So the value which comes to the device is 0111 and 0111. Okay, you can see that at this stage both the devices are opting for 0111. Okay, it will not change. And now this, you can repeat it, you can repeat. So what value you have got here at the device is 0111. It goes through the NOT gate again, it becomes 1000 and 1000. Okay, again selection at the arbitration line, the value becomes 1000 and it is returned to the devices as 0111. Okay, so this is the device which is selected by both the devices which is competing. Okay, you can take any example and try this. Uh, we are taking for a 4-bit number, a 4-bit ID means maximum of 16 devices can be there because we are using 4 bits. Okay, maximum of 2 power 4, 16 devices can contest with this 4-bit ID. Okay, so here by taking the example of 0101 and 110, by comparing you can see that the device B will gain the control, okay, and device B will become the bus master. So in the exam you need to draw this diagram. Okay, you need to draw this diagram and just explain theoretically that these are the values, some id is given to the devices. Okay, and depending on the id, the bus arbitration line values are mapped. Okay, so if at least if one bit is 0 and then that line value becomes 0. Okay, and finally the devices will select one particular device as the bus master. Okay, okay, that's about bus arbitration. Okay, bus arbitration, that is selection of the device to become the bus master. Okay, and transfer of the control of the bus to that particular device. Okay, so thank you for patient hearing.